In this video, we're going to get some practice with conjugate acid-base pairs. All right, so first problem is to write the conjugate base for each of these. Now the conjugate base is just going to be whatever we have minus an H plus. So if I've got HCl, I can get rid of the H and make it less positive. Well, if it's neutral, that means making it negative overall. So I get rid of the H and I get rid of a positive charge, and I'm ending up with Cl minus. In the case of H2O, same concept. I'm going to remove an H, and since it's neutral, I will remove a positive charge and make it negative. So it becomes HO minus or OH minus. This is the hydroxide ion that we've seen before. Next, HNO3. That's the nitrate anion with an H plus. So I get rid of the H plus and I end up with the nitrate ion. And then finally, in the case of H2PO4 minus, I'm just going to remove one of the H's and I end up with HPO4. And since it was already negative, I'm going to make it even more negative. It's going to be -2 because I'm removing a positive charge. Moving on, we're going to write the conjugate acids for each of these. Now the conjugate acid is just a case where we're adding an H plus. It's the opposite of what we did before. So if I've got Cl minus, it needs an H, and since we had a negative overall charge, if I'm adding a positive, it goes from -1 to neutral. In the case of H3O, I'm adding an H2O, so it becomes H3O, but since I'm adding an H plus, it needs to be H3O positive. NO3 minus, well, if I'm adding an H, it becomes HNO3, and since I'm adding a positive charge, the negative becomes neutral. And then finally, H2PO4 with a -2 charge, HPO4 with a -2 charge becomes H2PO4, and the -2 with a positive added to it becomes -1. All right, so that's that. Moving on, we've got some equations here, and we're going to see the conjugate acid-base pairs. So if I look at HCl plus Cn minus at equilibrium with HCN plus Cl minus, I see that the HCl has become Cl minus by losing an H plus. So you can diagram it as follows. That H plus transfers over from the HCl to the Cn minus, and I'll label this right here. So if the HCl is losing the H plus as we go rightward, then we can say that the HCl is the acid. I'll label it A1, and the Cn minus is the base, so I'll label that as B1. And as I go to the other side, you can see the Cn minus has picked up an H to become HCN. So actually, if we were to go in reverse, that HCN would be acting as an acid and transferring its H plus over to the Cl minus. So I can actually show that here. If we're talking about going leftward, then HCN gives its H plus to the Cl minus as we go from the right side to the left. So I would say that my conjugate acid is the HCN and my conjugate base is the Cl minus. So that's my B2. So our acids are HCl and HCN, and our bases are Cn minus and Cl minus. Moving on to this next one, we have NH3 plus HF, giving us NH4 plus and F minus. So as I look from here to here, it looks as I go rightward, the NH3 has picked up an H plus to become NH4 plus, and the HF has lost an H plus to become F minus. So my transfer is going in this direction, where I have an H plus going from HF over to the NH3, meaning that the acid is going to be HF, and the base is going to be NH3 as I go in this direction. But on this side, If I'm going leftward, then the NH4 plus is what is losing the H plus, and it's giving the H plus over to the F minus. So what I'll do is draw the arrow going here. Whoops, there we go. And this is now, sorry, this is my A2, my conjugate acid, and my B2, the conjugate base, because as I go leftward, the NH4 plus gives the H plus to the F minus, forming NH3 and HF. So that's that. Hope the video has helped. Feel free to leave any questions or comments in the comment section below. Thanks for watching.